The next thing that we're going to talk about is the intermediate value theorem. And our intermediate value theorem helps us locate the zeros of a polynomial function. So if you can find an x value where f of x is positive and then another x value where our output f of x is going to be negative, then there has to be a zero somewhere in between those two x values. Okay? So then you can repeatedly narrow down your this should not have an e at the end, your interval between the two x values to approximate that zero. So in example number 13, we're going to list all of the intervals of length 1, okay, from this table below, which the polynomial function f of x equals x cubed minus 3x squared minus 4x plus 5 is guaranteed to have a 0. Alright, so all I'm doing is I'll look at my x values in a second, but I want to look at my y values here and see between any consecutive y values there's a sign change. So we have no change, no change, no change. Well, we have a change here. This is a negative to a positive, so that means that your graph is going to cross the x-axis at some point. There's no change between these two. I've got a change between these here. It goes from a positive to a negative, so your graph is crossing back down over the x-axis. No change, and then a change right here between negative 7 and 5. Those two outputs, that's indicating that your graph is going to come back up over the x-axis. So the x values that this is occurring in between is what I need to be talking about. Okay, these are open intervals, so I need to have open parentheses. So it's happening between negative 2 and 1, between 0 and 1, and between 3 and 4. So these are the x values that I'm listing where the y values is changing from positive to negative or from negative to positive. Okay. So what we're going to do now is we are going to graph this function on our calculator. So we have, this is the same exact function as above, so, well, I don't want to put it there. X cubed minus 3x squared minus 4x plus 5. So the first thing that I want to do is I want to show you how this appears in your table. So if I just go to second table, okay, and then I want to look here, all these outputs are exactly the same as the outputs that I have here. So between negative 2 and negative 1, we change from a negative to a positive output. Between 0 and 1, your outputs went from positive to negative. And then down here, from 3 to 4, our outputs went from negative to positive. Okay, so I'm just going to very quickly write these down. And then the next thing that we're going to do is we're going to figure out exactly where those zeros are located. So I want to graph my function. Okay, I'm going to change my window. I did something yesterday. Okay, and you can see here that between negative 1 and negative 2, your graph is definitely crossing that x-axis somewhere in between. We're going to figure out where that's happening. Between 0 and 1, your graph is coming back down across the x-axis, which is awesome. So we know that we'll have a 0 between there. And then between 3 and 4, the graph is coming back up. So let's calculate our zeros. I'm going to start with the leftmost 0. Okay, and we're going to round to 3 decimal places, so we'll have negative 1.571. That value is definitely between negative 2 and negative 1. And let's find the next one. The next one here I have 0.857. And that value is definitely between the interval of 0 and 1. And lastly, The 0 is happening here at 3.714, and 3.714 is definitely between 3 and 4. Okay, so once you've watched all these videos and you fill out your notes, you can then show your completed notes to the substitute teacher to get your homework for you to start working on.